All right, so this is a continuation of the parts of the wave and the C equals wavelength times frequency equation. So you will probably have encountered this graphic in your textbook or online, which shows the different wavelengths of the different types of light and the different frequencies. So you can see that as your wavelength gets bigger, your frequency gets smaller. You can also see this is also referenced as the electromagnetic spectrum. You can see gamma rays, X-rays, ultraviolet, the visible spectrum, infrared, microwave, FM radio, AM radio, and then long radio waves. These are all different areas of light and on the spectrum. Okay, so the photoelectric effect was Max Planck proposed the relationship, and he said that energy is equal to Planck's constant times the wavelength, the frequency. So energy is in joules and V is frequency, so that's seconds to the -1 or hertz. And Max Planck's constant is 6.626 times 10 to the -34th joules times second. So you're going to need to remember that number so that you can plug it in. And oftentimes this equation is linked up with the speed of light equation in order to allow you to take wavelength and convert it into frequency and then find the energy. The photoelectric effect is a photon is a particle of electromagnetic radiation having zero mass and carrying a quantum of energy, and that energy depends on the frequency of that radiation. So we use that equation. So here's a sample problem. Microwaves have a frequency of 3.8 times 10 to the 10th hertz. What energy is associated with this type of light? So the first thing that we're going to use is our equation, and we're going to plug in our 3.8 times 10 to the 10th seconds to the -1, and we're going to multiply it times Planck's constant to find the energy. So you plug it in, you do the math, and you get 2.5 times 10 to the -23rd joules. All right, so you have two equations now, and they can be linked up through the frequency being in both equations. Okay, so make sure that you remember that Planck's constant, and you remember speed of light, because they are both numbers that you'll be expected to remember and use on your tests.